Thank you. It's my delight to be here in Goa and interact with so many smart people. We're going to go from a really philosophical and important discussion to a very technical discussion. So I hope you are ready for sort of a change in your thought process and mind today. So my talk today consists really of two parts. A useful part for practitioners and sort of a research part and sort of a deep dive that I hope that at least some of you will find interesting and compelling. So the first part is to introduce the event query language as a tool to conveniently search for malicious behavior in event streams or logs. And that was released just a few weeks ago, an open source, so I'm introducing it here for the first time at NullCon. And second, I want to talk about a machine learning model to help discover unknown malicious behavior in logs. So you know something bad happened in here, tell me what was bad, okay? So for that second part, please understand that I'm a researcher and I can't help myself, and I'll be jumping into some detail about the machine learning model there. So for some context today, I've been studying artificial intelligence machine learning since the late 90s, and now work with an excellent R&D team at Endgame, where I'm the chief scientist. And a small selection of things that you may have come across from Endgame and my team include Artemis, which is a way to interact with your enterprise network by, instead of a query language, by actually typing natural English. So show me process injection on my network, right? I type that. Or Malware Score, which is a lightweight standalone machine learning model, which actually we released an open source version called Ember, and anybody today can go download Ember and build their own next-gen AV model that useful for research. Most of my talks at research companies have actually been red team oriented, so I spent a lot of my career figuring out how to use machine learning against itself. So using machine learning to attack and evade a machine learning model. And what I'll be talking about today, of course, just prior to NullCon, we released EQL, the event query language, which is a useful way to both define analytics and to hunt, and also to do simple IOC search. So I just want to make sure, just for my information, can you raise your hand if you're familiar with the MITRE ATT&CK framework? Okay, awesome. I'm glad to see that a lot of people are getting to that. So hopefully many of you will become more and more familiar with this over time, but in fact, attack, ATT&CK, is sort of a knowledge base of attacker techniques and behaviors that span Windows and Mac and Linux, and can be used to navigate throughout that knowledge base. So the reason that attack is important, and I'll be talking about it today for context, is that it's become totally insufficient for you to defend against an adversary using simple indicator to compromise. Instead, if you focus on these sort of durable tactics and techniques that an adversary uses, you'll have much more success in finding an adversary who's living off the land or doing fileless attacks and things like that. So for example, consider the attack at the bottom that suppose you have a trusted third party like a law firm who has access to your network. So he has a login. He gets access through a trusted account. He downloads and executes PowerShell scripts that are run in memory only. He maintains persistence through scheduling a task. He escalates his privileges using UAC, user access control bypass. He might move laterally using WinRM, which is a tool that probably most of you use. And he communicates with his command and control server using something like domain fronting over SSL, so you don't really know what's going on. So that is a logical chain of events that you're not going to find with an IOC. So you need to focus on behaviors, and attack helps you to find what those techniques and behaviors are. Okay, so I want to just, as an example that I'm going to refer to later, just dive in one cell of this MITRE ATT&CK framework, and it's squibbly-do. So this is using reg-serve32 to execute arbitrary code without launching it directly. So it's a way to register and execute a COM script using this registry, and actually the file never has to hit disk. It's actually, if your reg-serve is a domain and HTTP stack aware, so you can actually point it to the web, it will download and execute, and it looks like there's a legitimate Windows application that's running. So this is an important technique for attackers, because if I have sort of a whitelist policy for running, guess who's running my script? it's a legitimate Windows binary that's signed and trusted, and it never touched disk. So this is one example of those, and it's used by many threat groups, including APT22 and 19 and 32. And I'll be talking a little bit more. I'll use this as a use case in just a moment. So, okay, so 2 parts to my talk. Number 1, how do I find, if I know a pattern, what's an efficient way for me to find this? And I'm going to try to sell you on using an open source tool that we've just released called Event Query Language, and I'll show you how to use that with some examples. And I hope you'll find it's actually pretty easy and intuitive to use, and it's complementary in some sense to other tools like Stix. There'll be a talk after this, or Sigma that some of you have used. So the second part of my talk, then let's suppose I don't know what exactly to search for. How can I try to learn? Like, what are the things I should search for, right, from data? So that will be using machine learning. Okay, so event query language. Let me just introduce this in the following manner. Event query language is not. Event query language is a way for you to take a pile of data, events of your choosing. Perhaps it's Windows event logs. Maybe it's sysmon from sysinternals, or for us, it's our end-game event logs. And you, independent of the data schema, you can define in a way that equal is aware of process context and process trees. And by taking a single pass through the data, you can make very efficient queries. So because it's a single pass through the data, it's useful for 2 things. It's useful for logs, and it's also useful for event streams, so as they're happening on the system. And in fact, that's how Endgame uses this, is as the events are flying by you, you build up this, equal allows you to build this state model that kind of understands and interprets the state of things as you asked for them, and it will trigger when that analytic you've defined is satisfied. So the language is actually really simple. It looks a little bit like SQL, but it's for event languages, so that's why it's called event query language. So the second part of this, so you can go today to github.com, endgame inc equal, and I can't today teach you how to use equal, but I can get you started. And go to this GitHub and check it out, and you're welcome to even follow along if you'd like. There's some examples in there. The second part is equallib, and equallib is a library of common techniques, so defenses for analytics for common attacker techniques. So if you're interested in looking in your own event logs for certain attacker behaviors, you can actually go today to equallib and use that as a basis. So essentially, if you're familiar with Red Canary's atomic red attack scripts that simulate attacker behavior, equallib kind of is mapping a one-to-one from atomic red to analytic against that. So today, the data I'm going to be using comes from Endgame, but you can, of course, use it for sysmon or Windows security events or what have you. Okay, so really quick, let me just dive in. And what does the data look like? The data comes is in its native form. It looks like JSON, and it has, there's really only a couple things that are important. It has an event type. So this is a process type, and it's a create process event. And it's being, this create process event happens because of this command line, regserve32, which is pointing to the internet to download this script that will be launched, right? So notice that each event has an event type and a subtype along with important data relating to the event. For example, the PID and the parent PID, the process path, the user domain. And of course, you could have hundreds of events coming per second, per user, per endpoint. And so querying these events efficiently and intuitively is really important. So I'm going to actually stop the presentation and jump to some data so you can sort of appreciate what that might look like. And so here's a JSON file. It's full of all of the events that happened on my system when I launched Atomic Red. So it includes, for example, here's command.exe that is copying the Atomic Red files to the disk. So I'm capturing even the setup. So think of that as the dropper for my technique. And then it also includes my regserve server 32 and all of the events that happen because of that. loading all these DLLs and executing the script, and finally, reaching out to the network, right? So what I could do to query this is in equal, I will say, let me query this file that contains all my events, process where command line equals, and I'm looking for the use of reg server 32 where it does anything that calls out to HTTP. And so when I do that, I'll then pipe it to JQ just to make the colors pretty for you all. And it finds the event that, in my maybe massive event log that corresponded to that. So if I were interested in, a simpler query, I could say, for example, let me find all the processes where anything happened, and let me just count the unique process names. So in this particular file, there are only 2 processes that were ever executed, reg server 32 and command.exe, each comprising 50% of all processes. So I hope that gives you just a hint of how sort of easy equal is to pour through a data set or an event stream. So I'm going to spend the next few slides going through some examples. And again, the use cases that my colleagues, when they released this, they wanted to cover not just IOC search, but also hunting. So looking for suspicious behavior on your system, and also straight up analytics. So can I use something to actually prevent malicious behavior? So first example, IOC search is not hunting, but it's an important part of your sort of daily hygiene. So to do that, you can say something as simple as this: process where process